Hello, our topic is, what is declination? Now, I answer this question in a series of 4 tutorial videos on astronomy for astrologers, but I want to present it here again for 2 reasons. One is I have a different way of presenting it, a different visual that I think might help make it clearer, and number 2, the information is buried in this very long series of videos. I mean, it's long because each one's a half hour, so it's a total of about 2 hours, and it's a question that comes up a lot. So for those 2 reasons, I'm making a separate video on this. Now, declination. We astrologers interpret declination. We have things like parallels of declination, contraparallels of declination. Many of you are probably familiar with the idea of out-of-bounds planets, which is also a way of interpreting declination. So, astrologers interpret these things, but what is declination? Astronomically, what is it exactly? And also, you may have heard the term right ascension, and right ascension be connected with declination. So I want to make this really clear. A lot of people have an idea about it, but it's not completely clear. So hopefully this will help. Well, to understand what declination is, let's go back to the basics of positional astronomy, also sometimes called spherical astronomy. 2 points that are really important. Sometimes if you don't understand these background ideas, these assumptions, you get lost because you don't get the basic assumptions. Number 1, in astronomy and in astrology, we often disregard the distance of celestial objects. By celestial objects, I mean everything out there. The stars and the sun and moon and planets and asteroids and so on. So in astronomy and astrology, sometimes we ignore how far away things are, and we think of the sky that surrounds us. And when I say sky in this context, I mean not only the visible sky, but imagine the sky that's below the earth and you can't see it. So that whole sky that's surrounding you, whether you can see it or not, is often referred to as the celestial sphere. And this is where I have a little diagram I want to show you. Here's my diagram, a beach ball. Our reality is a beach ball. We all live in a beach ball. I'm thinking of that song, We All Live in a Yellow Submarine. Well, we all live in a beach ball. So the beach ball is actually a good image of the celestial sphere. Where are you and me in relationship to the celestial sphere? We're in the center of it. So this is a translucent ball. It's a very good image of what the celestial sphere is. It's just set out there amidst this grass and hedges or whatever this is. So here's this translucent ball, and you and I and everybody else on planet Earth are in the center of it. So all you have to do is imagine that you live in the center of a beach ball, and you look out, and we disregard that the stars and the planets are different distances away from us as we're in the center, and we imagine that all of them are the same distance from us, and they're all on this sphere. Now we know that that's literally not true, but you can do a lot of calculations in astronomy using that assumption, believe it or not. Even though the assumption is wrong, it still works out mathematically. So that's the celestial sphere. Okay, you got it? So celestial sphere is, you just make believe everything out there is the same distance from us, and we're in the center of the universe, even though we're not. Some of us may think we're the center of the universe. And so we're in the center, and here's the celestial sphere all around us. So we're living inside a beach ball. Okay, now living inside this beach ball, inside this celestial sphere, how do we talk about where things are? If I want to get on the telephone and tell somebody, oh, the fixed star Sirius or the fixed star Regulus is in a certain direction of the sky, or Jupiter is in a certain direction, how would I describe it? Well, the way that it's often described is with a spherical coordinate system. And here's how the spherical coordinate system works. This brown or reddish brown lines, curved lines, is what I want to focus on. For now, disregard the different colors and this blue, and let's just focus on the fact that we have a sphere, and we have this, I'll call it brown, this brown circle at the top, with lines radiating out of it, and reaching this line here, okay? Let's just focus on that. This represents, this line here is the ecliptic plane. I'm using this to represent the ecliptic plane. The ecliptic plane is the path of the sun through the sky. So the sun will go around the sky, essentially going round and round once a year, every year coming back to the same point in the sky. And that path of the sun is called the ecliptic plane. Now these little white dots, my idea here is that these white dots are on the celestial sphere, and they are planets. Maybe this is Mars, maybe this is Jupiter, maybe this is Mercury, whatever they are. And remember, this is geocentric. We're in the middle. So we are in the middle, and the whole sky is on this sphere, and the planets are here, near but not on the ecliptic plane. Question, is that realistic? Is that what happens? Are the planets near the path of the sun, so that if you drew a line from one planet to the next, you'd get this kind of crooked line, not a perfect line like the ecliptic plane, but almost on it. Is that what would happen? True, yes or no? Answer is yes, that's exactly what happens. The planets are near the ecliptic plane, but usually not exactly on the ecliptic plane. Okay, so what we do in astrology is we make believe the planets are on the ecliptic plane, essentially, and that position on the ecliptic plane is the zodiac longitude. 30 degrees of this ecliptic plane is called Aries, and the next 30 is called Taurus, and the next 30 is called Gemini. So all this stuff may sound abstract, but this is the heart of astrology. This is the zodiac that's so fundamental in astrology. And there's a way of picking a starting point and then dividing it into 30-degree sections that are signs. And the planets are very, very close to it. What does this have to do with declination? I'm getting to it. Just hold on a second. You really have to have this background information to appreciate all this. Okay, so this is the ecliptic plane, and this is the pole of the ecliptic plane. So when you make this circle, called a great circle, a circle that goes around the celestial sphere, right around the middle of it, and you can have, an infinite number of middles, just any circle where the center of the circle would be where we are in the center, just a big circle going around. It's called a great circle. And that great circle is going to have two poles, right? 90 degrees in one direction and 90 degrees in the opposite direction, and those poles will be opposite to each other. So when you have a great circle and you have a pole, so this is, we'll call it the north pole of the ecliptic plane. Now this north pole of the ecliptic plane is not the north pole that we think of, where Santa Claus is or something. That north pole geographically is, that's a different north pole. So any coordinate, it's called a coordinate system, has its own north pole. Okay, so the point is this. Planets, we make believe that they're on the ecliptic plane, and that's its zodiac longitude. And what is the distance from the ecliptic plane called? Okay, some of you have learned this stuff already. Do you remember, if you've learned some of this? What is this called, this distance? If this is a planet, this white blobby thing here, and what is this distance from the ecliptic? That's latitude. It's not declination. Some of you may have said it's declination, and this is one of the confusing things I've seen. I've listened to astrologers lecture on this and say it incorrectly. I've seen it in books and blogs and stuff. Incorrectly stated. The distance of the planet from the ecliptic plane is not declination, it's latitude. And this word latitude is used in a lot of different ways. You know that there's a latitude of where you live. The city you're in has a longitude and latitude. The longitude and latitude of where you live we call geographic longitude and latitude is something different. So that makes it confusing. These terms are used in different contexts to mean different things. So this is ecliptic longitude and latitude, in astrology sometimes called zodiac longitude and latitude, where longitude is the measurement along the ecliptic plane and latitude is the distance of the object from the ecliptic plane. Okay, so planets are always near the ecliptic plane, and the distance from the ecliptic plane is called latitude. The sun, by definition, always has no latitude, because that's what the ecliptic plane is. The path of the sun has 0 latitude. It's always somewhere right on the circle. And the other planets waver up and down a little bit above or below the ecliptic plane. Okay, so what does this have to do with right ascension and declination? What it has to do with it is that there are other coordinate systems. To make a coordinate system, you just need a great circle. And to get right ascension and declination, you don't use the ecliptic plane as your great circle. You got the idea? You can create any number of coordinate systems. All you do is make a great circle. In this case, the circle is the path of the sun, and then you measure along that circle. Well, right ascension and declination has to do with using a different great circle. And those of you who have studied this before, do you remember what the great circle that right ascension and declination are based on? It's called the celestial equator. So this blue circle, I didn't draw it very well. I got a picture of a beach ball and I drew my own lines on here. I have no artistic talent. It's amazing I managed to do it even that well. So this blue, which is at the center of these beach ball sections that were already on this beach ball, so I didn't have to draw those. They're there. This is the North Pole relative to the celestial equator. And this North Pole is the pole directly above our geographic North Pole. And this equator is the equator of the Earth extended out into the sky. That's why it's called the celestial equator. This is our equator, but it's out in the sky. We're here in the middle on planet Earth, and if you took our equator and extended it out into the sky, it would hit these points on the celestial sphere. So this is our equator extended out to the celestial sphere, extended essentially infinitely out, and that's called the celestial equator. And we can measure along the celestial equator, and when we do that, it has a strange name. Instead of being called longitude or something, normal, easy to think of, it's called right ascension. So it sounds weird, but right ascension is the measurement off the, along. Right ascension is the measurement along this celestial equator, and I didn't draw it very well, but this is supposed to be the pole of this. This is supposed to be 90 degrees, going around this. I think this probably should have come up here. I probably didn't draw it very well, but you have the idea. This is the where all these colored sections meet, and they're going to meet at the opposite point, right below it. And then if we go halfway between these poles, I probably didn't find it very well, but we'd have some point halfway in between, which would be a great circle, a big circle around the ball, and that's called the celestial equator. Now, the distance from the celestial equator is called the declination. So, hallelujah, I'm now 14 minutes into this lecture, and I finally told you what declination is. Declination is the distance of the planet from the celestial equator. So you have different coordinate systems, and using this particular coordinate system, this is the declination. So which of these planets, if these are 4 planets, and they're always near the ecliptic plane, which of these has a very high declination, a very large declination? This one, this one, this one, this one. Which ones have big declination? Very simple. This one does. Relatively. These are close to the celestial equator. This one's relatively far compared to these two. And this one's relatively far as well. So these two have a large declination. Large, maybe it's 10, 20 degrees. These are close. they only look like they're just a few degrees. If it's, it's 90 degrees from here to here, it's just a few degrees. So these have very little declination. That's why a planet has a longitude, its zodiac position, in other words, along this ecliptic plane, and a latitude. Notice this object, if these are north and this is south, this planet, for example, would have a south latitude, just a little south of this, maybe just 1 or 2 degrees, very close, and it would have a north declination, and so on. This object would have a north, or does have a north latitude of just a few degrees, and it has a north declination, which is bigger. So that's all it is. Declination is the distance from the celestial equator. Now, the thing that's amazing or interesting is that in astrology, of course, we interpret the zodiac longitude. That's the big deal, right? My Mercury is in 18 degrees Aquarius, or, my moon's in 19 Pisces, etc. That's the position along the ecliptic plane. We usually don't talk about latitude, but for some odd reason, which I'll explain in a minute, there actually is a reason for this, we, astrologers, interpret the distance from the celestial equator. So something that seems inconsistent is we interpret longitude, but we don't usually interpret latitude, right? I mean, I don't hear people going around saying, oh, my Mercury and Venus have the same latitude, celestial latitude, therefore, I'm a writer or whatever, something, interpretation. We don't do that very much, which is interesting. And then we don't interpret right ascension very often. I mean, if you're a technical astrologer, you know situations where we use right ascension. But, overall, we don't use it that often. But we do interpret declination. So it's interesting, with these coordinate systems, we use one coordinate, the longitude along the ecliptic plane, to interpret the longitude position, which is the main thing that's interpreted. And then also sometimes astrologers interpret the declination, which is the distance from the celestial equator. Okay? So we're all living in a beach ball, right? To summarize, we live in a beach ball. And in this beach ball, you can create coordinate systems by putting a big circle around you. And that circle is called a great circle. And that circle will have a pole, a north pole and a south pole. And you can measure where an object is along that great circle and how far above and below it is, that great circle the object is. And declination is the distance of a planet above or below the celestial equator. So that's what it is. Now, it may sound bizarre. Why would anybody care? Why are we making such a big deal out of it? I will give you an intuitive feeling for why declination could be important, but that's what it is. Okay, you got it? So that's what declination is. All right, let me go back to my notes here. PowerPoint slide. Make sure I covered everything. I did, but to review, my point number 2 is that we describe a celestial object by a spherical coordinate system. A coordinate system consists of a great circle and the poles of the great circle. 3 common spherical coordinate systems, right? They're spherical coordinate systems. Ways of measuring on the celestial sphere are the ecliptic, zodiac longitude and latitude, equatorial, right, which is called right ascension and declination, and the horizon is another one, which I'm not going to talk about here. I talk a lot about this in the tutorial videos on astronomy, and the measurement along that is called azimuth and altitude. So that's what declination is. Now, a couple of more points. You'll often hear about this 23 north 27, 23 south 27. What's the deal with that? The deal with that is this is the celestial equator, the blue one. This brown one I'm calling the ecliptic plane. Well, this is going to reach a maximum distance apart. And then this blue circle is going to come back up and intersect the ecliptic plane. So these 2 great circles, the blue one, the celestial equator, and the brown one, the ecliptic plane, will intersect at 2 opposite points. And the greatest distance between them is 23 degrees 27 minutes. And therefore the sun's maximum declination is 23 degrees 27 minutes. It varies a little bit over long periods of time, but about 23 degrees 27 minutes is that maximum distance here on one side, and then on the opposite side it'll be, the blue would come above the red, the blue circle would come above the red circle by the same amount. And the distance between the poles is also 23 degrees 27 minutes. And here my diagram's not very good. These look much closer than 23, 27. They should be further apart. So my diagram isn't technically drawn the most perfect way, but the concept is good. These should be actually a little further apart. But that doesn't matter. You got the idea. Okay, so that's where this 23, 27 business comes in. You hear a lot about it because that's the maximum declination of the sun. Okay, and there's a lot of other interesting things. Where the celestial equator crosses the ecliptic plane, that's your 0 Aries. That's where the zodiac begins. 0 Aries and 0 Libra, those two opposite points. So this is either 0 Aries or 0 Libra, and then the opposite point is 0 Aries, 0 Libra. Anyway, there's all kinds of interesting things here. But 2327 is the maximum declination of the sun. It'll go up to north 2327 and then down to south 2327. Now, a few other points, and we've completed our description of what declination is. First of all, why do we care about declination? Who cares that we're a certain distance from the celestial equator? Well, if two planets have the same declination, they travel the same diurnal path. Diurnal path means the path of the planets through a day, through one day. So note that all planets, fixed stars, etc., travel in parallel diurnal paths. So planets rise in the east, they come to their highest point, we call culminate, they set, and everything in the sky is rising and culminating. Everything in the sky is making a circle roughly around the star we call Polaris, at a point very close to Polaris, the North Star. The whole sky is spinning around in a circle each day with these parallel, or you could call them concentric circles. So if two planets have the same declination, they have the same exact diurnal path. That's visually and intuitively why it's interesting, because this is all an optical illusion, because the Earth is spinning on its axis and the whole sky appears to be spinning around. And this path of objects around the North Star is sometimes called the diurnal arc or nocturnal arc, the part of it that you can see that's above the horizon, often called the diurnal arc or the nocturnal arc. You'll also hear this phrase semi-arcs, which simply means half of the arc, such as from rising to culminating, or culminating to setting, or setting to what we call anti-culminating. As the objects in the sky spin around the North Star, if they're far enough away from the North Star, they will rise and culminate and set, and then we call anti-culminate. So anyway, you'll hear phrases diurnal arc, nocturnal arc, semi-arc, or diurnal path. These are all essentially the same thing. Nocturnal arc is the part of the path below the horizon. Diurnal arc is the part above the horizon. Semi-arc is 1/4 of that path. There are 4 semi-arcs, and the whole path is called the diurnal path. So when you hear these terms, they're all referring to the same basic thing, which is the diurnal path of a planet, and it's that diurnal path that relates to declination. It suggests that declination might be important, or at least it's visually interesting, that planets with the same declination follow the same diurnal path. Okay? Now, another few points. You will sometimes hear, very likely, you may hear somebody say, particularly an astrologer, that declination gives a 3D perspective on a planet. or it's the other coordinate, or it gives the complete picture, or they'll say it gives the total description of where a planet is. Do you agree with that? Let's go back to the diagram. Would you say that declination gives the 3D view of where a planet is? Yeah, I mean, you can interpret these words however you want, but to me, it really doesn't. Longitude and latitude would give me a full description of where the object is. It's still not 3D because it doesn't have anything to do with how far away it is. So essentially, latitude and declination get mixed up together sometimes. And remember that declination is the distance from the celestial equator, and latitude is the distance from the ecliptic plane. So longitude and latitude go together. Zodiac longitude and zodiac latitude are partners. They're two parts of identifying where an object is. And right ascension and declination go together as the two coordinates that describe where an object is in relationship to the celestial equator. So I just wanted to make that clear because sometimes astrologers don't understand this, and it's like the blind leading the blind, and this gets really confusing because now people are trying to get clarification and they're getting wrong information. So I'm not saying that every time somebody uses these phrases, 3D perspective, that they don't understand what they're talking about. They may perfectly understand what they're talking about. But I just want to make sure that the language doesn't deceive or confuse you, because it confuses me. For me personally, it's not giving me a 3D perspective. They're just different measurements, as I just explained. So I just wanted to clarify that, because there's a lot of confusion about this declination thing. And I also want to point out that diurnal paths, which is closely related to declination, because two celestial objects with the same declination have the same diurnal path. Diurnal paths are important in astrology. They're extremely important in ancient astrology. They're the foundation for many kinds of primary directions, which are based on nocturnal arcs and diurnal arcs. You calculate these semi-arcs. These calculations of these arcs, which are the arcs depend on the declination of the planet. Very, very important in a lot of ancient astrology because they're very conspicuous visually. You see the planets rise and culminate, and that path depending on the declination of the planet. And they're also used for calculating the positions of houses. So a lot of astrologers use placid as houses, and you may not know it, but your houses are calculated based on determining things, based on determining the diurnal path of something, right? It gets a little complicated, exactly what it is the diurnal path is of. And I don't want to get into all that here, but my point is these diurnal paths are very important historically in astrology, and they work into the way we interpret things, and one of the ways it works into it is declination. So declination is really part of this awareness that planets rise, culminate, and then set in a path that's determined by its declination, or you could say the declination is the measurement of where that path is. Okay, so all right, so some clarification on what declination actually is, because like I said before, there's a lot of confusion about what these things are, and sometimes some misinformation or why it's used. So I hope that clarifies it. Let's see if I've got any other slides here. Oh, one last thing, and I believe this is my last slide, because you'll see this as well, the football diagram, and when they use the word football here, this is an American term. In America, we call football soccer, and then we have another sport we call football. So anyway, Americans sometimes call this the football diagram. It was developed by K.T. Borer. I'm embarrassed to say I never got the correct pronunciation of her name, which is Catherine. She is credited as the person who developed the idea of out-of-bounds planet. She's credited with inventing the term. I believe she was the one who introduced the football diagram, but she was a highly respected person who put a lot of emphasis on declination, gave examples of charts, and really made some strong arguments that declination is important. And out of bounds just means a planet that is outside the path of the sun. It's beyond 23 degrees 27 minutes. And I'll show you an example of it. Last thing we'll do here. Well, here is, I didn't resize this to fit on the screen. Well, let me do some resizing here. And it's a little bit messy here. Just do this real quickly. Just resizing this to fit on the screen. Okay, that's good enough. Here's the chart of Stephen Forrest, the astrologer. And just to show you this football diagram for him, I'm in the Sirius 2.0 software. I'll go to Listing and select the Declination and Latitude Graphic Display. Maybe I should have called it the Declination Football Graph, because that's what a lot of people call it. But I just called it the Declination Latitude Graphic Display. And up pops this window. It's a resizable window. I'll make it a little bit bigger. And you'll see this diagram a lot, so I thought I would show this to you. And it tells us at the bottom that the celestial equator is red. That's the celestial equator. Here, we're taking the celestial sphere and putting it on a flat surface. That's the same exact thing we do with a map, isn't it? We take when we take a map of the globe, and we put, North America, South America, Europe, and Africa, and everything on that flat map. This is the same exact thing, except we're taking the sky and putting it on a flat surface. It's the same exact idea. And this is the celestial equator. It tells me down here that the green, this is the ecliptic plane. This is the path of the sun. So here's the sun when Stephen Forrest was born, and notice it's right on the ecliptic plane. Does that surprise you? No, of course, it's got to be on the ecliptic plane. It's going to be somewhere on this path. And planets in this fuchsia color are out of bounds. Does Stephen have any out of bounds planets? One, Uranus. Right just a little bit above this maximum point. This would be 23 north 27. This would be 23 south 27. The sun is never out of bounds, right? Because it can't go out of bounds. But the other planets can. Here's Pluto way over here. It's if we look at the positions, here it lists the positions. Pluto's exactly at 23 north 27. It's right at that point, and determined to be, in this case, I guess, some tiny fraction below 23 north 27, that point. So it stayed blue, and Uranus just above it. So you see the one planet that's out of bounds. So any planet that's out here is called out of bounds because it's outside the range that planets usually stay within. They usually stay within 23 degrees 27 minutes of the celestial equator, and occasionally they can move outside that range. And when the planet is near 0 degrees Cancer in zodiac longitude, or 0 degrees Capricorn, somewhere reasonably close to that, maybe within 30 degrees or so, that's the only time the planet can go out of bounds. Because when a planet is in Cancer, it has its highest, Gemini in Cancer, it has its highest latitude. And Sagittarius in Capricorn, it's lowest. So anywhere down here is out of bounds, and also over here is out of bounds. Anyway, I wanted to show you this, quote, football diagram, because it's another way of looking at it, and it's often used. And it's handy, because you can see that for Stephen, he has, Venus, Jupiter, and Sun, and Mercury, and Mars, and all kinds of things very close to being out of bounds, but not quite. I'm going to make another tutorial video immediately following this one, probably, where I talk about how you interpret these things. Okay? Losing my voice here, sorry. So this video is about what declination is. I'm also going to make another little short video on some hints about how you interpret particularly out of bounds planets, or even planets that are near out of bounds, such as in the Stephen Forrest chart. He's got many planets near out of bounds. Pluto's very close to out of bounds, and Uranus just a little bit out of bounds. Okay, so that's it. That's what declination is. Many people say, I'm confused. Well, I kind of got the idea. I know the words. I'd like to understand this better, so I hope that helped. Gave another visualization of it, and you know, I have as I mentioned before, I have those 4 videos on astronomy for astrologers, and other videos on how you calculate house customs and so on. So there's a lot of material here on getting the astronomy behind astrology clear, and you know, this. I hope that this one helps to make this make it clear in your mind what declination is. Okay, thank you very much. Take care. Thanks for listening. God bless. Namaste.